What if the sixth mass extinction isn't some distant future? It's happening right under our noses.
We're seeing birds vanish from our skies, insects disappear from our windshields, and the reasons are surprising.
Data shows extinction is accelerating 100 to 1,000 times the natural rate, and it's not random.
Stay with us as we reveal the drivers, debunk myths, and show how you can make a difference.
Today, we unpack the insect apocalypse and bird decline through evidence, moving beyond sensational headlines together.
We'll start with how the sixth mass extinction differs from the Big Five and why it matters now.
Then we'll dive into data from Germany, Puerto Rico, and beyond, cutting through controversy and confusion.
You'll hear real stories and new research, plus how our community is already making a difference.
One more thing. Yes, we are AI-generated hosts, but our mission is human. Transparency and trust first.
So hit pause for sources anytime, join the pack in comments, and let's begin this journey together.
Earth has survived 5 mass extinctions from meteors and volcanism, but the sixth is different. This time, one species, humans, drives the crisis by consuming resources at exponential rates worldwide.
Let's call it the Anthropocene extinction, and evidence shows a biological annihilation already underway today.
We measure extinctions by comparing current rates to the background rate, about 1 per million species years. Refined estimates suggest the natural rate is closer to 1/10 per million species years, meaning species last millions of years.
Today, extinctions are happening 100 to 1,000 times faster, far beyond natural variability.
Since 1500, at least 73 animal genera have vanished, a loss that should take tens of thousands of years. Functional diversity is declining. Entire branches of the tree of life are being severed already.
Scientists warn that we are outside the safe zone for biosphere integrity, with 60% of land at high risk.
Our focus today narrows to insects and birds, the tiny engineers and feathered storytellers that underpin ecosystems. Insects make up most animal life, pollinating crops, decomposing waste, and feeding countless species worldwide.
Birds act as indicators when they disappear. It's often because the insects they eat are already gone.
Many viewers have noticed fewer bugs on windshields and quieter dawn choruses. You're not alone. We'll explore the data behind these impressions, starting with the famous Krefeld study in Germany.
For 27 years, researchers trapped flying insects in nature reserves and found a 76% decline.
The drop was consistent across habitats, and despite plant diversity being intact within reserves, remained steep. The implication is clear. Even protected areas can't escape the intensification of agriculture surrounding them today.
The windshield phenomenon is real in North America too. Quantitative reviews confirm declines in moths and butterflies.
Long-term ecological research sites initially showed mixed signals, leading to a heated debate we'll unpack later. Meanwhile, tropical forests, home to most insect diversity, are experiencing what some call a biofamine.
Most people don't notice when the forest goes quiet. Here in Puerto Rico, insects are vanishing. In Puerto Rico, arthropod biomass dropped 4 to 8-fold between 1976 and 2012 sticky.
That collapse triggered declines in lizards, frogs, and birds, showing a bottom-up trophic cascade. Climate warming in the Luquillo rainforest raised temperatures by 2 degrees Celsius, exceeding insect thermal tolerance.
In Costa Rica's Guanacaste, once thick clouds of moths have vanished, starving caterpillars, parasitoids, and birds.
Researchers there link the decline to irregular rainfall and rising temperatures, disrupting essential seasonal cues. Data gaps in the Amazon, Southeast Asia, and Africa mean our understanding is incomplete, but deforestation and monocultures hint at losses.
We'll consider these data gaps carefully and why they matter when drawing global conclusions.
Next, we'll examine debates among scientists and why meta-analyses sometimes report less dramatic declines. Before we dive deeper, share in the comments. Have you noticed fewer insects or birds where you live?
Your personal observations help connect our science to your world. We'll highlight a few later on.
Let's unpack the evidence with precision and caution. Not all studies agree on the scale of decline. The Krefeld study is robust, but some meta-analyses report declines of 9% per decade, not 76%.
Klink and colleagues found terrestrial insects declining about 9% per decade while freshwater insects increased.
Critics argue that freshwater increases reflect recovery from polluted baselines, not truly healthy ecosystems anymore. Crossley et al. Claimed no net decline at U.S. research sites, suggesting winners balance losers.
Yet their data was criticized as rotten because sampling effort increased over time, inflating apparent abundance.
Some meta-analyses included non-insects like spiders and crabs, significantly muddying the overall signal today, unfortunately. Overall, terrestrial insect decline remains consistent across independent datasets, despite lively methodological debates among scientists.
We do see increases in freshwater species. Policy interventions like the Clean Water Act may explain rebound.
We must also consider data gaps. Deforestation in Amazonia and Southeast Asia is rampant but poorly monitored. In Africa, insect declines are inferred from collapsing bird populations, so direct measurements are scarce.
Now let's explore drivers. This isn't just about numbers, but about systems interacting in dangerous ways.
Chemical synergy matters. Fungicides once thought harmless to bees block detox enzymes, amplifying insecticide toxicity. When bees exposed to propiconazole encounter sublethal insecticides, mortality rises dramatically in field conditions, shockingly.
Landscape studies show fungicide use predicts range contractions for declining bumblebee species, clearly and rapidly.
Climate and toxicants interact. Heat waves lower the safe limit for pesticides by stressing organisms further. In honeybees, combined heat and fungicide exposure reduces the odds of returning to the hive.
That fragmentation and climate synergy trap species. They can't shift ranges when landscapes are carved into monoculture.
Fragmentation increases edge effects with hotter, drier boundaries that desiccate moisture-dependent insects and amphibians severely. Light pollution is another overlooked driver, drawing nocturnal insects out and disrupting mating behaviors seriously.
Declines in nocturnal pollinators ripple to bats and nightjars, affecting plant reproduction and food webs.
Phenology mismatch is yet another mechanism. Climate change desynchronizes plants, insects, and migratory birds today. Plants and insects respond to temperature cues, while birds migrate based on day length or internal rhythms.
The result: birds arrive on breeding grounds when insect peaks have passed, starving chicks sometimes.
The Great Tit System in Witham Woods shows oak bud and caterpillar timing shifting faster than bird breeding. If mismatches exceed about 24 days, models predict population collapse. Adaptation may not keep pace.
Long-distance migrants like pied flycatchers fare worse because they cannot predict European spring from African cues.
Populations in the Netherlands have declined by around 90%, where mismatches are severe already. Warmer winters allow resident great tits to survive, increasing competition and even fatal clashes with flycatchers.
The phenology research shows some species adapt by tracking biomass rather than peak abundance, adding complexity.
However, relying on larger, later prey may trade off nutrition and hasn't been fully studied. The consequences of insect and bird loss extend directly to our own food and health.
75% of crops need animal pollination. Declines already create measurable yield gaps.
Global studies show 28 to 61% of crop systems are pollinator limited. That's huge. Pollinator-dependent foods provide vital nutrients like vitamin A and iron. Deficits cause hundreds of thousands of deaths annually.
While pollinators contribute billions of dollars to agriculture, over $1.5 billion in the U.S. alone.
Insectivorous birds save farmers money. In Jamaica, birds controlling coffee pests boost yield by about $100 per hectare. In Washington, birds reduce spruce budworm outbreaks, saving thousands per square kilometer in timber annually.
Poachers are obligate scavengers. Their collapse in South Asia led to millions of feral dogs. Without them, carcasses linger, fueling explosive dog populations.
This triggered a rabies outbreak estimated to cost tens of billions of dollars and tens of thousands of lives.
Dispersal by large birds influences forest carbon dump. Losing frugivores reduces potential carbon storage by 60%.
Dung beetles cycle nutrients and reduce methane emissions. Their decline leaves pasture lands covered in manure.
All these functional losses highlight how insects and birds underwrite services we rely on daily. We are also approaching tipping points. Ecosystems can collapse abruptly once stress crosses a critical threshold.
Importantly, reversing collapse requires reducing stress far below the tipping point. A hysteresis effect indeed exists.
You know, some folks say insect decline is overblown because of data gaps. Is that fair?
I get why they're cautious, but when 76% of biomass vanishes, it's hard to call it hype.
True, but some data sets were messy. Meta-analyses show milder declines. How do we square that with personal observations?
Maybe by recognizing differences, freshwater insects rebound thanks to clean water laws, while terrestrial species get no reprieve. Yakoski ichiki.
And by acknowledging that synthetic voices like ours don't change the data, we follow the evidence.
Speaking of voices, our community wonders about AI hosts, transparency matters, and the data stays the same.
Agreed. On synergy, chemical cocktails and heat waves mean it's not just one driver. Do you have a favorite example?
I keep thinking of bees on heat waves. One extra degree and suddenly safe doses become lethal.
For me, the night being stolen by light pollution is compelling. Moths turned into easy prey under street lamps.
Then there's habitat fragmentation. and animals can't migrate to cooler regions when surrounded by monoculture fields.
Absolutely. And climate mismatches, birds following day length while insects follow temperature, timing is everything.
It's like showing up to dinner after the buffet is cleared. Chicks starve because the caterpillars have peaked.
I love that metaphor. But some may ask, can't evolution catch up? Maybe, but pace matters.
Some species adapt by switching to larger prey, but that might mean less nutrition or new challenges.
So there's nuance. Decline doesn't mean everything disappears overnight. It's about functions eroding before extinctions.
And that's the scary part. Ghost ecosystems look intact until you realize the services are gone.
Here's a question for our viewers. Which driver worries you most? Chemicals, fragmentation, climate, or something else?
Let us know in the comments, and if you have field notes or photos, share them so we can map.
Community science can fill data gaps in the global south. Your notes might matter more than you think.
We'll feature the best submissions in a future spotlight, because seeing patterns together is powerful.
Also, if you come across claims without sources, ask for evidence. Healthy skepticism keeps us honest.
And if we ever miss something, call it out. Our pack thrives on constructive pushback.
In that spirit, let's briefly myth bust. Are declines just cyclical? Data shows declines are sustained, not seasonal.
Another myth, bugs always bounce back, but some declines reflect functional extinction where interactions vanish.
Exactly. In ecology, tipping points mean recovery isn't guaranteed. The hysteresis effect means you can't just undo damage.
That's why action now matters. Delaying interventions could lock ecosystems into degraded states for generations.
We'll explore specific case studies next to make these concepts tangible and show where hope lies.
Grab a snack and get ready for some real-world stories that connect the science to people and places. Let's start with farmland birds in Europe. They've plummeted by 57% since 1980 due to intensification. Hedgerows removed, pesticides sprayed, and fallow fields lost. These green deserts starve both insects and birds.
Common species like sparrows and blackbirds aren't exempt. Europe's common bird populations declined by 25% overall.
In North America, we've lost nearly 3 billion birds since 1970. That's 29% of breeding adults. Grassland birds were hit hardest, losing more than half their numbers. Forest birds lost 1 billion.
These aren't rare species. They're the backyard birds many grew up with, underscoring a deep ecological unraveling.
Aerial insectivores like swifts and swallows depend on aeroplankton, flying insects. They've declined up to 59% in Canada. In the UK, spotted flycatchers collapsed by over 90% and red-backed shrikes disappeared entirely.
Migratory birds crossing the Afro-Palearctic flyway face double jeopardy. Habitat loss on both breeding and wintering grounds.
Stopover sites in the Sahel and Mediterranean degrade, turning long flights into death marches for these travelers. The vulture crisis in South Asia shows how functional extinctions become human crises too, sadly. With vultures gone due to diclofenac poisoning, carcasses rotted, feral dogs exploded, and rabies deaths skyrocketed.
The cost was measured in billions of dollars and tens of thousands of human lives.
Seed dispersal is another invisible service. Losing frugivores reduces carbon storage potential in tropical forests by up to 60%.
When big birds are hunted out, forests shift toward light-wooded species that store less carbon.
Dung beetles, the unsung heroes, recycle nutrients and cut methane. Their decline leaves pastures choked with manure.
This harms soil fertility and increases greenhouse gases, linking insect conservation directly to climate mitigation.
Pollination deficits already reduce yields in nearly 61% of crop systems. Farmers feel it in their wallets. A shortage of wild bees means less fruit, vegetables, and nuts, which supply vital vitamins and minerals.
Studies attribute roughly 427,000 excess deaths annually to reduced intake of these micronutrient-rich foods.
In Jamaica, birds eating coffee borers boosted yields by up to $105 per hectare.
In Washington, avian pest control saved thousands per square kilometer in timber by limiting spruce budworm outbreaks.
These examples show that saving insects and birds isn't just altruism. It's pragmatic and economically wise. But hope isn't lost. Some freshwater insects rebound when pollution is reduced, suggesting policies work.
The Clean Water Act reduced industrial pollution, allowing aquatic species to recover, showing collective action matters.
Similarly, organic farming and regenerative agriculture can foster insect diversity while still feeding people successfully. Planting hedgerows, reducing pesticides, and leaving fallow strips give bees and birds safe havens too.
Citizen science, like backyard counts and photo submissions, helps fill data gaps and empowers communities.
Our viewers have already shared notes on insects and birds. We'll feature some in our community spotlights. One pack member, Sunrise Surfer, sent photos of her once busy garden now eerily quiet. We'll revisit that soon.
We also received track photos from a rural farm. Verifying them reminds us to check for double-registered prints.
When community evidence arrives, we consult experts and compare with field guides before drawing conclusions. Our Pack's Pun of the Week segment features Believe It or Not, submitted by Musketeer Chris. Keep them coming.
Humor aside, these micro-connections keep retention high and remind us that science communication is about people too.
Next, let's zoom out to planetary boundaries. We've already crossed the biosphere integrity threshold.
7 of 9 planetary boundaries are breached, with biosphere integrity and climate change tightly interlinked.
Operating outside these safe zones reduces Earth's resilience to climate shocks and makes recovery harder.
Bifurcation models show ecosystems can absorb stress until a threshold, then suddenly collapse into a new state.
Once collapsed, restoring ecosystems requires reducing stress far below the tipping point, a hysteresis effect. With those sobering stories in mind, let's celebrate our pack's contributions and highlight your voices next. Welcome to our Community Spotlight, where we celebrate you and your passion for wildlife and science.
First shout-out goes to EcoWarrior77 for linking a study on butterfly declines in his backyard.
He noted a 30% drop in moths over 5 years. Thanks for sharing your data, friend.
Viewer Garden Gazer asked if we should build insect hotels. Absolutely, and we'd love to see your designs.
We also heard from Holland Pal, whose kids counted bees for a school project and discovered far fewer than last year.
These contributions reveal local trends that global datasets miss, filling those data gaps we discussed earlier.
Don't forget our pun of the week. What did the Beatles say at lunch? Leave me alone. Keep them coming.
Some of you asked about AI transparency. Our team is 2 humans using AI voices to scale our storytelling.
We love your honest feedback and will keep showing behind-the-scenes glimpses to build trust.
Channel Growth Update. Our last micro short on wildlife crossings hit 2.5 thousand views, proving real-world solutions resonate.
Your likes, shares, and comments fuel the algorithm and help bring these stories to more people.
If you haven't already, tap subscribe and ring the bell so you don't miss upcoming deep dives.
We also launched a poll asking which species translator you'd like next, wolves, coyotes, or huskies.
Vote in the community tab after the video and share why you chose your favorite. Data helps us prioritize.
Superfan Luna Howls sent a howling clip after our dire wolf episode. Thanks for the pack energy.
We'll compile these fan sounds into a future montage. Keep sending them, and maybe your voice will feature.
Remember to tag your comments with your region when reporting insect or bird changes. It helps contextualize.
Some of you asked about AI rights and ethics. We'll plan a transparency segment in an upcoming episode.
If you're new here, drop a comment with your favorite animal and how you connect to nature.
We read every comment and often reply. It's the highlight of our day and informs our scripts.
If you love data, please post sources when you cite stats. We'll pin some in the sources panel.
Finally, a quick gratitude howl. Thank you for helping us reach higher retention and building a science-loving pack.
Up next, we'll look toward the future and innovations that could turn the tide for insects and birds.
Looking forward, there are reasons for cautious hope if we act decisively and collectively now. Policies like the Clean Water Act show that regulation can enable insect recovery when pollution is reduced. Adopting regenerative agriculture, less tillage, more crop diversity, fewer chemicals, boosts soil health and insect diversity. Urban planners can dim streetlights, use warmer hues and shield fixtures to protect nocturnal insects. Farmers can plant hedgerows, wildflower strips, and cover crops to provide essential habitat and corridors. Gardeners can choose native plants, avoid neonicotinoids, and let parts of their lawns go wild for pollinators. Citizen science apps like iNaturalist help track species. Your photos become data for researchers worldwide. Emerging technologies, like acoustic insect sensors and AI classification, can monitor populations effectively and non-invasively. Researchers are studying climate toxin interactions to update pesticide safety limits for hotter future conditions ahead. Some countries are considering banning certain fungicides that synergize with insecticides, protecting bees and other pollinators. Efforts to reconnect fragmented habitats through wildlife corridors can help species migrate as climates shift. International agreements on biodiversity and climate must recognize the codependence of biosphere integrity and climate stability. Indigenous stewardship offers lessons. Many communities manage landscapes sustainably and protect keystone species wisely and already. Ultimately, hope comes from collective action and acknowledging that small changes by millions add up. Stay with us as we wrap up with actionable takeaways and a hopeful closing message. First takeaway: support policies that reduce chemical use and protect habitats. Contact your representatives today. Second, create insect and bird-friendly spaces at home. Plant native flowers, install water sources, and skip pesticides. Third, join citizen science projects. Log your observations and help scientists understand patterns and gaps. Fourth, stay informed and critically evaluate claims. Consult our sources panel and share credible information. Finally, subscribe, share this video, and join our pack. Together, we can foster a healthier planet.